Hello and welcome to your favorite Shridevi Classes YouTube channel, where we inculcate interest and confidence in class 12th physics, which remove all sort of confusions and improve scoring ability. Today in our subject Electrostatics, we'll discuss charging by induction, where a conductor body without touching another charged body get charged by induction. We'll also discuss behavior of conductor in electrostatic field. Let's start. What is charging by induction? In metallic conductors, inner orbital electron with nuclei form remaining atom which is positively charged, and outer orbital electron acts as free electrons and behave like negatively charged carrier which can roam freely within metal by thermal agitation energy, and these electrons can shift their position, and with that shifting can shift charge when an electric field is applied over metallic conductor. Such electric effects can be produced in metallic conductor by the presence of charged bodies in near proximity. Here, when we brought a positively charged rod near metallic conductor, mobile charge carrier electrons get attracted towards positive charge and concentrate to an end which is near to charged positive rod, and this shift of electron generate concentration of positive charge to other end of metallic conductor. Now this charge displacement by the presence of nearby charged object without any contact is called charging by induction. In metallic conductor, charging by induction is a temporary phenomena and it will last so long as we keep a charged rod nearby to it. If this charged rod is removed from this nearby position, this transfer of free electrons will vanish and this metallic body once again become charge-wise neutral. Also, charging by induction is possible only in conductors which have free charge carrier as electrons, which can move from one position to another position by the electric effect phenomena of nearby placed charge. Such charging by induction will not take place in insulators which won't have free charge carriers. When we place a charged metallic rod near to a neutral metallic conductor, it will induce charges and produce net attractive force between two. So attraction is not a sure test of presence of charge on both bodies. A charged body can attract neutral metallic conductor. Attraction is not a confirmation of presence of opposite polarity charge on two bodies can be proved by this simple example. We have 5 conductor pairs A, B, C, D and E, and among these pairs B and C has a repulsive force. D and E pair also have a repulsive force, whereas A and B have attraction force, B and D have attraction force, and A and D also have attraction force. Now repulsion between B and C confirm that they have like polarity charge. Similarly, repulsion between spare D and spare E confirm like polarity of charge on D and E, and an attraction between B and E clearly indicate that the charged spare have opposite polarity charge on them, and here if A attracts to B and A also attracts to D, create a confusion because B and D have opposite polarity charge and they both are if making attraction with spare A, then it is confirmed that it is a neutral metallic conductor, and this attraction with B and this attraction with spare D is by charging of induction. Temporary produced induced charges in a metallic conductor by the presence of nearby charged object can be made permanent by grounding connection of metallic conductor at suitable position. When this positive rod is placed near to this metallic conductor, electron will shift by attractive action of this opposite positive charge, and concentration of electrons here produce negative charge, and deficiency or shift of electron here generated positive charge. And when this positive end of metallic conductor is connected to ground, it will attract electrons from ground structure, and incoming electron from ground neutralize this deficiency of electron charge or presence of positive charge as shown here. So now we have only negative charge placed at one nearer end of this metallic conductor which is close to positive charge rod, and this positive charge rod generate an attractive force to retain these electrons in this position. Now if ground connection is disconnected first and this metallic rod is kept here, then we will get net negative charge on this metallic conductor, and such charging of neutral metallic conductor by presence of nearby charged object and grounding connection is called charging by induction, and it always produce opposite polarity charge on a metallic conductor. This concentration of induced charge also become uniform if we remove this nearby charged object, and if this charge rod is removed from this position, we will find induced charge uniformly get distributed on metallic conductor surface, and induced charges always have a polarity opposite to the polarity of charge which has induced these charges. This step process can very well explain charging by induction in a metallic conductor by the presence of nearby charged object and grounding. For charging, a metallic conductor should be placed on an insulating post, and when a charged rod, say positively charged, is placed near it, electrons of metallic conductor will transfer themselves and they will concentrate as an opposite polarity charge close to this nearby positive rod, and far away position of metallic sphere become positively charged due to shift or deficiency of electron from this part of sphere to this part of sphere which is close to this charged rod. Now if far away position is earthed, then electrons will move towards sphere B and neutralize this part of induced charge, and charge on other part of sphere remain as it is due to induction phenomena of nearby charged rod. Now if earthing is disconnected first and nearby charged rod is kept as it is, this induced charge will become net charge on this sphere, and if this nearby charged object which has produced induced charge on sphere B is removed, then the charge on sphere B will uniformly distribute itself as shown here. So we found that charging by induction will require two things: one, presence of nearby charged object, and earthing at suitable position. Here negative rod is brought near a metallic conductor. Mobile free electrons get repelled by this negatively charged rod and will concentrate at far away position. When this far away position is grounded, this negative surplus electronic charge will go to ground position and get neutralized, and if ground connection is disconnected first and this rod is kept as it is, we will found that this metallic conductor will have induced opposite polarity charge on it, and if this rod is also removed, this charge will distribute itself uniformly over this metallic conductor. In a specific condition, we can produce charge on metallic conductor by induction without any ground connection, as here we have two spherical metallic conductor on insulating post touching each other. When we brought a positively charged rod A near these two touched spheres, then electron of both spheres will concentrate to one end of sphere B which is close to nearby placed positively charged rod, and deficiency of electron to far away spherical position generate positive charge. Now if we gently make separation between these two sphere B and C which are mounted on insulating post, then we will found that due to induction, one sphere B will get negative charge which is opposite to polarity of nearby placed charged rod, and other sphere will get positive charge which is similar to this nearby placed charged rod. Now this induced charge on sphere B and C will remain on these spheres even when that nearby charged rod is removed from this position. But if these two sphere B and C are very close to each other, then this opposite polarity charge will concentrate in a non-uniform manner as shown here. These two opposite polarity charge have a tendency to attract each other, and if we increase separation between these two spheres and if they are kept very far away, we will found that induced charge will distribute itself uniformly over sphere B and C. Air friction or rubbing action on metallic conductor can transfer electrons and produce static charge on metallic conductor. Such vehicle which are carrying highly inflammable material always have a attached metal piece or rod or chain which connect metallic body of vehicle to ground position. In fact, when such vehicle move, air friction can generate charges on moving vehicle, and such charges can generate spark and initiate flame and explosion to inflammable material handled by this vehicle. So for safety, such container are connected to ground by a chain or rod to discharge all charges which are produced by friction activity continuously to earth connection. Similarly, to handle static charge effect, tire of all aircrafts are made slightly conductive. Aircrafts can acquire too much amount of charge by friction, and to save aircraft from any unwanted situations due to sparking of charges during takeoff or landing, tires of aircrafts are made a little conductive so that in place of making spark, charge can transfer easily to ground through conductive tires. In metallic conductors, free electrons are mobile charge carrier, and any electric field or potential difference in a metallic conductor can transfer continuously these electrons. Since source charges are stationary in electrostatics, so position of charges which is producing electric field in electrostatic should not move, and this is possible only when there won't be any potential difference in metallic body or there won't be any internal electric field in a metallic body. So all conductor bodies, whatsoever their shape and size, will behave like an equipotential body with zero internal electric field. Since electric field is produced by electric charges, and for zero internal electric field there should be zero value of internal charges. So all charged body, whether they are positively charged or negatively charged, the charge will remain only on outer surface and not in internal positions, and there won't be any internal electric field in a metallic conductor, and all electric field will exist external, and that too normal to the surface. For example, here we have two concentric sphere, one inner sphere of small r and another sphere of radius capital R which is greater than small r, and if inner sphere A got some charge, then that charge will produce some electric field and potential difference between two spherical surfaces as given by this relation, and if we make any connection of electric conductor among these two spheres, as per condition of electrostatics, two metal surface should have the same potential, and for equipotential positions of two spheres there should not be any electric field or potential difference between two spherical surface. So this capital Q charge which is on inner sphere should move to outer sphere in all conditions so as to produce zero potential difference between two spherical surface, and in zero charge condition there won't be any internal electric field or potential difference between two spheres, and in all conditions charge will remain only on outer surface of conductor body. With the help of this learning video, you have understood conductor behavior in electrostatic field and charging by induction. Our other video of the same playlist will improve your physics understanding and make physics simple, interesting as well as scoring. If you like our study material, do share it with your friends, and to get study notes, online and offline classes facility, join our YouTube membership. Thank you very much.